So I just want to ask you, how many of you here consider yourself like an expert in cloud computing? Cool, selection bias, because which expert would come to a basics talk? So let me introduce you to Emily. Emily right here is a self-taught data scientist, as I think most of you are at this conference. She's familiar with most data tools in machine learning and data science stack, like scikit-learn, maybe some deep learning library. And she's also comfortable with creating web apps for her models. Like she want to go and show like her family, oh, I made this model that detects this picture as of a cat or a dog. So at one point in time, Emily starts working for an awesome company, along with Jacob, who is a machine learning engineer, and Noah, who's a product manager. And yeah, one day Noah comes and he tells them, so legal's team wants a document classification model. And at the moment, Emily starts thinking like, oh, cool, I can create the model and deploy it in a Dash app, a Streamlit app for the legal team to upload their document and get it classified. And that's when Jacob goes and says, sure, we can set up Emily's model as a containerized Lambda function triggered by S3 object uploads and save a prediction to some DynamoDB table notifying legal team whenever a record for a document gets inserted using DynamoDB streams. And at that moment, Emily was like, I have no idea, no clue what this guy just said. So given there, this talk is very likely for you. I want to just list some points why I think cloud computing knowledge is important for you as a data scientist. So the first one is going to be, you'll feel more confident with designing solutions. So you'll understand most of the things that Jacob said. It will help you bridge the gap between the model's development phase and its deployment, which is something I have struggled a lot when working with data scientists. It will also give you freedom to explore your personal projects. So once you have a project running in your local computer, maybe you know what tools to use to put it online. This is a very important one. It will give your debugging skills a 10x boost, which is crazy how much time you will save in debugging. And then understand what is happening under the hood. Maybe your company has a platform as a service in which you go and click deploy and some magic happens in AWS. So my idea is that you understand what happens there. This talk is going to have 3 pillars. So the first one is going to be compute, as we need somewhere to run our models or data pipelines. The second one is going to be storage, as we need somewhere to save our data sets and predictions, and maybe our models too. And the last one will be monitoring, which is we need to be able to identify when things go wrong and why, which is very important. Sometimes we just put the model in predictions and let it run, like, go and do your thing. The talk is going to be around Amazon Web Services, kind of controversial in Microsoft offices, but anyways. Mainly because of market share, and secondly because of my personal experience. So I'm going to give you some preliminary knowledge of AWS, like some general things, which are going to be useful to you. So the first one is AWS infrastructure is composed of regions, and each region is composed of 1 to many availability zones, which I will call ACs because availability is a hard word. This is a map of all the AWS regions that currently exist. And as you can see in Sao Paulo, we have 3 ACs. And you can think of every AC as a data center. So if one AC goes down and you have your model running in 3 of those ACs, it's going to keep running because just one of them went down. If you're working with the AWS console, you very likely have identified this bottom in the top right corner, in which you can select your region, and we can cause you some headaches sometimes, which you come to the console and you see you don't have any instances running, and it's because you selected the wrong region, just that. Then there's the concept of a virtual private cloud, which is a VPC, which is no more than a range of IPs that is assigned to your account in one specific region. And then you have a subnet, which is a range of IP addresses inside your VPC that can either be public, these ones are accessible through the internet, or private, which are not. And also you need to understand that some AWS resources run inside your VPC while others run in the AWS network, which means you would have to go through the internet to access them. There are some exceptions in which we can bypass that. And finally, AWS handles permissions via identity and access management. I am using policies, which is a JSON that looks like that. Like, okay, allow this whatever I'm putting this policy into to do this kind of actions on this resource. And they can either be attached to your users or an IAM component like user, groups, and roles. Okay, so compute. Before I start this section, I want to go over the debate of fully managed versus serverless. You might have heard it. So fully managed means you have to configure the scaling, provisioning, networking of your servers and virtual machines. You will get billed for the time that your virtual machine is up, which leads to some unexpected costs. I think everybody has seen those. And you're free to add any dependencies and run most kind of workloads on this kind of machines. And then you have the serverless, which is you get automatic provisioning and scaling of your resources. You will get billed for execution time and not the time that your machine is up, if it's not doing anything, for instance. But you will get a bit more restrictions like on the execution time, payload size, and the code size. So the main service for running fully managed virtual machines on the cloud in AWS is Elastic Compute Cloud, EC2. And for serverless, it will very likely be Lambda. Lambda is a function as a service, which is serverless too. And there are some other serverless services like AWS Glue, which I think most of you have used. And also AWS EMR has also released their serverless version. So what I was mentioning about the fully managed part is that for running an EC2 instance, which would be no more than a computer running in the cloud, you would need an AMI, which is just our virtual machines OS. So you've got a list to choose, like Linux, Mac OS, Ubuntu, and so much more. They would need to choose your instance type, which would be resources such as this amount of CPU and RAM that your instance is going to have. Then you will need to select the settings for your networking, for instance, and which VPC you want to run it, and at which subnet. And finally, the amount of storage you want that instance to run. So once you've got all those four pillars, you can start running your EC2 instance, and you can literally run most of the things. Like you can host a web server, you can run high-performance computing workloads, you can run a database if you're brave enough, and you can run analytical and machine learning tasks, and to infinity and beyond. Really, anything that you can run on your computer can be taken to the cloud using EC2. And then we have Lambda, in which we have two main requirements. The one is just code. You can just go to the service, complete the Lambda handler, and that's how you get a function running. And then memory. And some of the main use cases for Lambda include event-driven applications, processing data streams, some small shard running workloads, and microservices. And if you're thinking, so can I run a model in a Lambda function? Yes. Actually, one of the companies that we worked for, we had all our models running in a Lambda, which made it extremely cheap because we didn't have to manage any servers, and we only got billed for the execution time of those models. And then containers come. So how do containers work in AWS? Luckily for you, Lambda comes already with an integration with Docker, so you can run a Docker image inside of Lambda, so that's quite cool. You can get running Docker inside of a EC2 instance, which is basically what I mentioned. If you can install the Docker engine in your machine, you can do it in the EC2 instance. And there's this thing called Elastic Container Registry, which would be the equivalent to Docker Hub, but in your AWS account. So that's where you would do like Docker push there, and then Lambda would pull Docker images from the ECR. And then another mention I want to do is container orchestration systems. So I think most of you might have heard of this thing called Kubernetes, which kind of scares us a bit. But it's real simple. I mean, it's just a bunch of computers running, which are called nodes. And we want to tell that container orchestration system, okay, so I want you to run this Docker image, which could be the legal's backend. I want to get 2 copies of this one running. So it just go like, okay, this one has available resources, I'm going to put it here, and then I'm going to put the second one here. And then it can go with my document classification model service and tell it the same, but I want 3 of these because, I don't know, I'm going to receive more requests. So I tell it, get 3 of these running, and it goes, okay, put it there, there, and there. And that's the basic of it. That's all that Kubernetes has, along some other things. What is the cool thing about container orchestration systems? If a container fails for whatever reason, the system is going to realize that, and it's actually going to create a new instance in whichever available node it finds. So that's all you need to know. You very likely don't want to create your own container orchestration system inside your company just to run a model, because you will get a lot of costs upfront. But if you already have one, and these are the two options that AWS gives us, you can really talk to the infrastructure team and put your models right there. So it gives us two possibilities. The one is Elastic Container Service, and the other one is Elastic Kubernetes Service. The main difference is that the one on the left is AWS proprietary, meanwhile the one on the right runs Kubernetes, which is an open source software. And then you have the serverless flavor to these, which is running on AWS Fargate, which is putting a container in a serverless environment. If all this confused you, there's this awesome AWS compute decision tree, credits to Servian, in which it not only goes to services that I went over, but a lot more, like machine learning services and analytical services inside AWS. It's quite cool. And this is the branch for the compute services. Moving on to storage, I want to mention 3 storage flavors that you can choose from. The first one is blob storage, which is just putting files in the cloud. The second one is like traditional SQL systems. And the last one would be a key value store, which is a NoSQL one. So for uploading files, I think most of you have worked or at least heard of Simple Storage Service, and in S3. For SQL, I'm going to present to you Relational Database Service. And lastly, for NoSQL, you have different services, but I'm going to show you DynamoDB, which is one of the services that AWS tends to be most proud of. Just bear in mind that you also have different alternatives for graph databases like Neptune and time databases like TimeStream. So Simple Storage Service, in essence, it allows you the creation of buckets, which are the core component where your object will live. Think of it like some kind of hard drive in the cloud. And each object has its key, which is analogous to a files path. So for example, for a full object, you would have it identified as S3, which is a protocol, legals documents row prod, which would be the bucket, and finally the object key, which we could have, partitioned by year, month, and date, and then the file name, which would be some doc.pdf. Some interesting features include object triggers, which means there are many of these, but I think the most important one is when you get a new object uploaded to S3, you can actually trigger something else on another part of AWS. Then you have something called lifecycle policies, which is you can define what happens to the objects after some time. For instance, after an object is uploaded, I want to delete it after 30 days because maybe it was something temporary. Then you have something called storage classes, which change the availability of your object depending on how frequently you want to access it. So you have like the standard class up to the Glacier Deep Archive. And logically, the standard class tends to be more expensive and the Glacier Deep Archive cheaper. But also, it takes more time to retrieve an object from the Deep Archive. Then you have automatic replication, which means you can upload an object to an S3 bucket and replicate it to another one automatically. Versioning, self-explanatory. You can have an object and just upload the same object and it's going to stack layers of versions. And one cool thing is that if you accidentally delete an object, which has happened to me, you will just get a delete marker. And if you want to restore that object, just delete the deletion marker, and then you have it. And so S3 is ideal for uploading your data sets like tabular, images, audio, and all kinds of files that come to your mind. It is cool for creating data lakes. And one other use case, it's cool for hosting static websites. So at this company I worked for, we had a process that uploaded an HTML with a report to S3, and we'd actually show that to management in an easy way. So we didn't have to carry our notebooks or whatever. They just went to that website and they could see the report for the metrics of the model. And one important thing is that S3 runs on the AWS network, so just bear that in mind. Then we have RDF, Relational Database Services. We have two possibilities here. The first one is that we can run traditional SQL databases like MySQL, Postgres, and such, which are managed by AWS. What do I mean with this? You just get an EC2 instance with the database software running, And AWS will handle software updates, security patches, and such. And then you have Aurora, which is an AWS proprietary software, but it is compatible with the MySQL and Postgres drivers. So if you're using a Postgres database in, I don't know, Azure, and you want to migrate to Aurora, it's transparent to your application. This database is run on your VPC. Please don't put your database on a public subnet unless you know what you're doing. And then you have, here's a comparison of Aurora versus RDS. So in performance, Aurora tends to be better. They have storage scaling. Both have automatic scaling, but Aurora has a bigger limit. So if you start getting your disks full, it will actually expand automatically. In Aurora, you can have up to 15 read replicas. So for those of you that don't know, most database clusters tend to have one writer database in which all writes go, and then read replicas, which would be used if you want to query the database, but you don't want to stress the writer database, which would be like the main one. And in RDS, you can just get up to 5 read replicas, and with no auto scaling, you just have to do it manually. Failover is this thing in which you have your writer database and your reader replicas. And if your writer fails, you actually want to take one of those read replicas and promote it to be a new writer. So you won't get any downtime in your application. In Aurora, it's automatic. In RDS, if you have multi-AC, lots of stuff, it's automatic. Otherwise, it's manual. And pricing Aurora tends to be more expensive than RDS, but I think it's worth it, really, unless you have good reasons not to. And finally, we have DynamoDB, which is a key value store. Very simply, you have a key which matches to some values. So in Dynamo, you have what are called tables. In this case, we have the people table, and the keys would be the person ID, and the values would be any other field that comes after. So you would have the last name, the first name, the phone, the address. Anybody who has worked with NoSQL databases know that this schema are flexible. So if I want to add a new field, I don't need to run any migration or any fancy thing. I just need to push a new object there and I get a new field. It is AWS proprietary. I recommend that you go and check the history of Dynamo. It's quite cool. It runs on the AWS network, so we'd have to go through the internet to get there. And then some features include that you can either use a partition key only or both partition and sort keys. Very detailed explanation. Then you can have global tables, which means if you're running a DynamoDB database in the US and then you want to deploy your application to Australia, then to reduce latencies, you can replicate the data across the world. You have caching of reads, which is using DAX. And then you have DynamoDB streams, which would be a change data capture feature in which every time you put a record in DynamoDB table, it would send kind of a notification, which can trigger different things in your infrastructure. In the image, we see that every time in your record gets inserted, it will trigger a Lambda function, which can do some other things. And then you have two flavors, which is either provision, which is when you know what kind of workloads you're going to receive, so your load is going to be predictable. And then you have on-demand capacity, which is actually going to scale it automatically. And finally, monitoring. I'm just going to go over the service called CloudWatch because I think most companies actually prefer using some other monitoring system like Kibana or spend all their bill in Datadog. And CloudWatch is quite simple service. It is the de facto service for monitoring services in AWS, and it's used mainly for handling logs, metrics, and alarms. And just some key line concepts, you have what is called a log event, which would be a record of the resource or application being monitored. Say when you run logging.info, one of those would be a log record. Then you have a log stream. So if we go back to the container orchestration, you can have two of those running. A log stream would be all the logs of one of those containers. And then a log group would be all the logs of absolutely all the application. One cool thing is that logs can be queried and filtered using logs insights inside of CloudWatch. And then some metrics concepts is that you have many services that provide free metrics by default. Like for instance, in Lambda, you get the number of invocations and the number of errors. You can also define your custom metrics. So for instance, I don't know, I want to send like the prediction a model gave me, and I send that metric to CloudWatch. And then you have alarms, which are defined based on metric values. So if I go back, I can just calculate the ratio of errors over invocations and trigger an alarm if that goes over, like, I don't know, 5%. And as data scientists, machine learning engineers and such, maybe you have heard of SageMaker. Has anybody heard of SageMaker here? And who is using it? Okay, cool. You're on the cool path. Why do I say this? So the first thing is that I just want to transmit to you that SageMaker tends to be just EC2 instances running all the time. So in SageMaker, you have like SageMaker pipelines, which are no more than machines spinning up all the time and just running the code that you give them. We evolve in there waiting like a machine 5 minutes to start and then failing, which kind of sucks. And then you have the SageMaker endpoints, which are, again, no more than EC2 instances, auto-scaling groups and stuff, but all in all, it's just EC2 instances. And the last thing that I wanted to mention here is, and why do I go over SageMaker? There's this thing called the vendor lock-in versus open source tools, which is, I think, something you need to have in mind all the time when working with cloud providers. So the vendor lock-in is when you, your provider forces you to adjust your projects to your vendor specifications. So for instance, you have your models running locally, and then when you want to take them to cloud, they give you like, okay, but you need to implement all this boilerplate just to get it running in my infrastructure. And then you have open source tools, which is not tied to any specific vendor, and they might be easier to move between them, and it makes really your whole development phase more flexible. As I mentioned, running ML workflows on SageMaker is tightly coupled to using its SDK and available resources. And as I said, open source tools are not tied to any specific vendors. So one of the cool tools that I've found lying around is SenML. I really recommend that you go check it out. It's a tool in which you can declare your pipelines and inference infrastructure in an abstract way, and then you can just run everything on the different clouds. Like for instance, in the pipeline that we see below, the pre-processing is getting executed in Kubernetes using Spark. Then the training is getting executed in SageMaker, and then we can finally deploy it to Azure. So back to Emily, based on what we learned in this talk and going over Jacob's description, all that he was mentioning is having a Lambda function, which, as he said, was containerized. So we would have a Docker image running in the ECR service, and the Lambda would pull the image and run the inference. We can also have an S3 bucket in which we will put our models, our serialized models, and we can make our function download those models and run the inference. And we can have another S3 bucket for the legal team to upload the documents. So automatically, when they upload a new document, it would trigger the execution of our Lambda function. We can then save the prediction, for instance, on a DynamoDB table, and that would trigger the execution of, for instance, a new Lambda function created by the legal team, which would be invoked via DynamoDB stream.